Here's an example where we're asked to solve a formula for one of the variables. So in this case, we have the equation A equals P times the quantity 1 plus RT, and we want to solve for R. So the goal is to completely isolate R in this equation. So if I'm trying to get at that R, then the first thing I would do is get rid of this P in front of it. That way I can at least have just what's inside the parentheses by itself. That would have me one step closer to getting R by itself. We're focused on the R right here. So if this is P times this entire quantity, then in order to get rid of the P, I have to do the inverse operation, which would be to divide. Opposite of multiplication is division. So divide by P on both sides. On the right side here, that'll cancel the P's, and so we have A over P equals 1 plus R times T. And again, here I'm going to write the R in red so we can stay focused on it. The goal is to get that R by itself. So next thing would be to subtract the 1. So then we get at least this whole term. So in this sum, we want the part of it that involves R by itself. So I would subtract 1 from both sides at this point. So now I have A over P minus 1 equals R times T. Times T. Okay. And again, the goal is to get R completely by itself, since this is R times T. Then to get that R by itself, I can divide both sides by T. Okay, now this is pretty ugly, actually. So at this point, I've got R by itself. R equals, but it's kind of a big mess. A divided by P minus 1 all divided by T. This is called a complex fraction, when you have like a little fraction inside of a bigger fraction, and we should simplify this. So the way I prefer to simplify complex fractions is to focus on, okay, because remember we did something I called clear the denominators. We talked about clearing the denominators when solving linear equations in the last section. I want to clear this denominator here. I want to clear the little denominator from the numerator here. And so I'm going to multiply by P. And that's perfectly legal as long as I multiply by the same quantity in the denominator, because then I'm multiplying this entire fraction by P over P, which is 1. And multiplying times 1 just leaves the expression leaves the quantity unchanged. Okay, so if I distribute this P in the numerator, then I'll have A over P times P minus 1 times P, so I'll just call that P, over T times P. Okay, and here the P's would cancel, and so now that numerator, so just this fraction, this little A over P times P, so here we're dividing by P and then multiplying by P. Those are inverse operations that cancels out. And so I have A minus P all over TP, right? And that's a nicer looking solution there. So I'd leave the answer like that. Looking back, sometimes with these, we sometimes call them literal equations, these equations involving a lot of letters. Looking back at the beginning, if you had decided to solve this a different way, often there are many ways to approach these problems. Suppose in retrospect, I mean, that gave us a fairly messy answer. What if we distributed the P first? So if we did that, that'd be another way of kind of getting rid of the parentheses there. P times 1 plus P times RT. So then I could subtract P from both sides. Remember, we're trying to isolate the R. So I could subtract P from both sides. That would give me A minus P. This is gone now, so equals PRT. And then, so again, focusing on I want to isolate R. So if this is P times R times T, I want to get R by itself. I can divide by P times T. That'll cancel the P, cancel the T. And that's fine as long as I multiply by the same amount on the left side there. And notice how, okay, then we arrive at that same answer. And in retrospect, yeah, that was a little quicker. we got to the nice answer a little faster, but either way is fine. And when you solve these literal equations, you may find your answer in different forms. If you're working on these problems, maybe with a friend from class, you might find one answer, your friend's answer looks different, but you'll be able to prove that they're actually equal to each other using some algebraic techniques.